Okay, in this video, we're going to do a fun little exercise. It's called Q Reconstruction by height. So what we're given is input, which is an array of arrays. And the elements inside are arrays, which are basically people. The first value is the height of the person, and the second value is how many people he or she sees, which are the same height or higher than he is, right? So let's look at the output. So we need to construct a function that would rearrange these people, so that, let's say this is the guy here, which is 4 feet tall, sees 4 people in front of them. Cool. So this is our output. So we see that like this guy doesn't see anyone. 7 feet guy doesn't see anyone that is the same height or higher than he is. The 5 feet sees 2 people, and so on. 6, 1, 4, 1 sees everyone else, and the 7 feet guy just sees another one that is 7 feet tall. Cool. So how to solve this? So if we look at the people, right, and the question basically boils down to we need to do some sort of sorting, right? So let's say if we first sort the people by its height, so the tallest one first, you'll see what actually happens here. So we have this guy here, then is the 6 feet tall guy, and so on. Now we sorted the array in place by the height first and the index second. So we need to sort it in a descending way, so the tallest people come first, and then if we have multiple guys with the same height, we sort it by second value in ascending order. So this is the trick here. And if we see, like, then we need to just insert the people inside our results array by its current index. So let's this guy sorted at index 0, and then the next guy at index 1, and we can see that what happens now is, like, when we insert 6 feet tall guy, it doesn't matter how many people we actually insert here. Like, we can insert it like 10 or 20 people, because we know that people that come after our current height, we know that they are smaller, and doesn't really matter how many people we inserted before or after it actually, yeah, it wouldn't even matter, right? So that's our solution. Let's quickly talk about time space complexity. So for time, because we are sorting the array, it's of n log n. So n represents the number of elements inside the array, and for space we will be allocating new array, so it's of n. Cool. So let's look how this would look like in code. So we will be printing our let's just call it my sort. Right, so the first thing we need to do is just sort people by height and by index, so by first value and by second value. So we can do that with Python's built-in functions. Just sort. We have key value argument, which we can pass lambda function. So first thing we need to do is sort by height in descending order, and then by next value. Cool. We will store all the values inside the results variable. So for height, example, we just need to insert into current index, current person. And believe it or not, we're done. At least I think so. Yeah. So let's look at the results. So here we have person that is 5 feet tall. He doesn't see anyone. 7 feet tall doesn't see anyone. And the next one, the 5 feet tall, sees two people. So he sees the two people are taller or equal height than he is. So this is correct. 6 feet tall guy sees 7 feet guy, and the 4 feet sees everybody else. So this is correct output. Yeah, thanks for watching and have a good time. Bye.